Hello folks, this is Mr. Henry, and we're going to try to continue where we left off yesterday. Sorry I can't be there today, my daughter has been throwing up. So we're going to try to finish off this lesson, this format. We don't actually have too much left to do. So if you remember yesterday, we learned how to solve an equation that was in the form like that. So if it was like x minus 3 and x plus 4, what we did is we set this one equal to 0 and solved. Add 3, x equals 3. Or we set this one equal to 0 and solved. Minus 4, x equals negative 4, and we got our solutions. Okay, so, ooh, that's no good. What did I just do? I don't know. Just want to grab the stuff. Lock. Lock in place. Thank you. Alright. It's not going to happen again, I swear. So here we go. That's how we solved an equation. Okay. We want to do that with what we have here. The problem is that is not two factors like this. This is just one big ugly mess. The second thing we learned how to do yesterday was factor. We learned how to take a polynomial and pull out a common factor. Those two skills combined will allow us to solve this equation. So check this out. From this problem here, I'm going to be looking for common factors. I'm looking at both these pieces, and I see they both can be factored by 2, because they're both even numbers. And they both have an x I can pull out. Now, if I do that, what's left behind? Well, from this guy, if I factor out a 2, I have no 2 left. If I factor out an x, I still have one x left behind. X times x is x squared. Over here, when I factor out a 2x, 8 divided by 2 is 4. And then if I factor out an x, I have no x's left over because I've already factored out that x. I've pulled that x out of the parentheses. So now look what I have left over. I have 2x times by x plus 4 equals 0. I have something very similar to that. I have something times by something else equals 0. There. This is one thing. This is another thing. So if I say, you know what, either 2x is equal to 0 or x plus 4 is equal to 0, I can solve. Divide by 2, x equals 0. Minus 4, x equals negative 4. I found my answer. My answer is either x equals 0, well, the points when x is 0 and when x is negative 4. Those are my solutions to this equation. That's the x values it would take to make the original equation true. If I would plug a 0 back in here for both these x's, 0 plus 0 equals 0. That's true. If I would plug a negative 4 back in for both of the x's, I would also get an equation that equals 0. Okay? So we factor the polynomial. Then once we have the factors, we use that zero product property to set both factors equal to 0 and solve both those equations. That's the goal for today. Letter B. So I'm going to take this and I'm going to factor. I'm going to see, what do these pieces have in common? Well, the only thing I see they have in common is the letter P. I can factor 1p out of both of them. So if this guy, if I factor 1p out, if I pull 1p out, I still have 1p left behind. Here, well, I've pulled his p out, I factored it out, but I still have this 3. And if you would double check it, if you would distribute this back out, you would get back to p squared plus 3p. Now, I have two things that are multiplied together that equal 0. So either p equals 0, that's the whole equation for this side, just p equals 0, or p plus 3 is equal to 0. Well, I don't have to do anything there. Over here, if I subtract 3 on both sides, p equals a negative 3. And we're done. So my solutions are p equals 0 and negative 3. You can write it like this combined, or you could just leave it as two separate solutions. Okay, a couple more. Let me see here quickly. Oh, we've got a bunch of examples. All right. So let's try it again. So I'm going to factor. Oh my goodness, there's a problem. I can't factor this because they're on different sides of the equal sign. So the first thing that we have to do is we have to get everything on one side. I have to have this set equal to 0. If it's not set equal to 0, we cannot do it. So I'm going to take this guy and I'm going to move him that way. I'm going to add h cubed to both sides. No, you cannot add these together. These are not like terms. This is an h cubed. That is an h squared. These cancel each other out, which is why I did that in the first place. Over here, I'm going to have h cubed plus 4h squared. Now I can factor. So looking at both my terms here, as far as the numbers are concerned, they don't have anything in common. This has a 1, that has a 4. There's no common factor there. Looking at the h's, yeah, I can pull out two h's, h squared, from both terms. They both have two h's they can give up. My first guy, if he gives up two h's, he still has one h left behind. My second one, if he gives up two h's, if I pull two h's out, both of his h's are gone, but he'll still have four h's, he'll still have the number 4 left behind. So here I have it. Two things that are being multiplied together that equal 0. So either h squared equals 0 or h plus 4 equals 0. This side's easy. We've solved this many times. Subtract 4 on both sides. H equals negative 4. Good. Other side, that's a little bit, it's been a little while since we've done something like that. Do you remember how to solve an equation that's h squared? How do you get rid of that squared thing? It's square root. You would square root both sides. And you get, well, h equals, it's still 0 because the 0 times 0 is 0. Like there's no, the square root of 0 is still 0. But that's how you would get rid of this h squared to make it just h. You square root both sides. And so those are my solutions. Okay, letter D. So, well, we're going to factor. And by the way, feel free to start working ahead a little bit. If you can work faster than me, let me skim through. There's not going to be anything terribly new here for a couple problems. It's going to be some of the same junk. So if you're able to work ahead a little bit. Don't get so lost you're not paying attention, because I want you to be able to check your answers. Make sure you're doing good, because if you're working so fast that you don't even know if you're doing it right or wrong, we're going to have some problems. But at least check it out here. So I'm going to factor here. These both, well, first off, it's set equal to 0. It's kind of important. So we're good there. But these both have an r they can give up. They don't have a common number factor. So if they both give up an r, this first term will be left with a 3r left behind. But think about that. Like, if he gives up an r, what's left over? You're going, well, there's nothing. But we can't do that. I mean, if we're thinking nothing, because think about this. If I would distribute this back out, yes, r times 3r is 3r squared. But r times 0 is not r. Like, what would this number here have to be so that r times... Oh, my goodness. So that r times by something is still r. If you're thinking it's a 1, you're absolutely right. It is a 1. Okay? That's what it has to be. So now r times negative 1 is negative r. Alright, so now we have this. Two guys multiplied together equals 0. So either r equals 0 or 3r minus 1 equals 0. He's already done. Other side. Add 1 to both sides. You always get rid of add and subtract before multiply and divide. 3r is equal to 1. Divide by 3, divide by 3. R equals, that's just 1/3. 1 divided by 3. I'm going to leave it as 1/3 as a fraction. Solution. So my solutions, my roots are r equals 0 and r equals 1/3. Okay. I recommend trying these two on your own. If you wanted to pause the video at this point and give a second for the students to try the problems, I'd recommend trying these two. And then when a few minutes has passed, a minute or two has passed, you can hit play and we'll go through them together. Okay. I'm going to start doing them now, though. So if you haven't paused the video and you want time to work, that's just pausing it quickly. Here we go. So, I cannot factor this because both pieces are not on the same side of the equal sign. It's not set equal to 0. I need that. So, I'm going to add 20m to both sides. So now these cancel out. It gives me my 0 I was looking for. On the left-hand side, these two pieces cannot be combined together, so I just bring them both down. Now, I'm going to factor. They both have a common factor of m. So if I factor out an m, I'm left with an m plus 20. Now I separate and solve. My solutions are either m equals 0, he's done, or m plus 20 equals 0. I subtract 20 on both sides, and m equals negative 20. Letter F. Ooh, this one's a little bit more complex, finally. So when I factor here, I'm going to factor out a 3k. They both have a 3 they can factor out, and they both have a k they can give up. So if I factor out a 3k, I'm left with a 3k. 3k times 3k is 9k squared. And the other guy, well, I factored his k out. And I factored out a 3, so there has to be a 2 left behind. 3k times by 2 is 6k. Alright, so when I solve, either 3k equals 0 or 3k plus 2 equals 0. Here, divided by 3 on both sides gives me k equals 0. On the other side, when I subtract 2 on both sides, 3k equals negative 2. Divide by 3, and k equals negative 2/3. There you go, my people in the back. So k equals negative 2/3 were my two solutions. Let me check my timing. 14 minutes. All right, we got time. These are the last two that we're going to work on in this format. Okay, so I want you to take some time, pause the video again, if you could please, pause the video, let the students work on these two problems, and then we'll go through them together. Okay? Alright, I'm going to go through them now. If you haven't paused the video and they're starting to work, pause the video now, please. Here we go. So, I'm going to start by subtracting 3y on both sides because I need those pieces to all be on the same side of the equal sign. I need it to be set equal to 0. These are not like terms, so I just have y squared minus 3y is equal to 0. I now solve. Oh, I lied. I'm not going to solve. I'm going to factor. I'm going to pull out a y from both of these because they both have a y they can give up. So if I factor out a y from both of these, I have 1y left over for my first term. Y times y is y squared. And I have a 3, negative 3, I can leave behind for my second term. Y times by negative 3 is negative 3y. If I continue to solve, either y equals 0, solution, or y minus 3 is equal to 0. I add 3 on both sides, and y equals 3 is my other solution. Last one, letter H. These both have an m that can be factored out. If this guy, if I factor out an m, I'm left with the 3 behind because my m got pulled out. Him, if I factor out an m, I still have one m left because one of his m's got pulled out. If I solve this, let's see, either m equals 0, and that's done, or 3 minus m equals 0. Check your solving the equations on this one. So, folks, if you're kind of someplace else, check this out. Because my guess is some of you messed up solving this. You should subtract 3 on both sides, because he's positive. Negative m equals negative 3. Then you would divide by negative 1 to cancel out this negative, and m equals a positive 3. So our solutions were 0 and positive 3. I'm going to talk about this, but I don't know how much of this we're going to do. So here's why doing problems like this can actually be a little useful. So in physics, there is this formula. This formula is used to calculate how long it takes an object that you've thrown to move in a parabola shape to get from start to finish. So let's say if I threw a football. So there is a nice big blue football. If I threw this football through the air with some initial velocity, I threw it really hard, it would go up in the air. At some point, it's going to turn, it's going to come back down. I could use this formula right here to calculate how long it's going to take that football to get from beginning to end. I could calculate down to the very second or half a second when it's going to hit the ground, if I knew the initial velocity, the initial throwing speed of the ball. Okay, so this is kind of an application. This is used a lot in physics. And so I have a couple little worry problems here that would relate to that. So I'll do one just to show you here. So I'm going to copy down this formula. I'll be honest, I don't have that stuck in my brain. That's a pretty ugly formula. So H equals negative 16t squared plus vt plus s. Was that correct? Yep. Now, the t is time. The time in seconds. The h is our final height. So like my football here, when I throw it originally, I'm throwing it from, I'm standing on the ground, or maybe when I release it, my hand is about 6 feet above the ground. But when the ball lands, its final height, if it's landing back on the ground, its final height would be 0. In most of the problems that we're going to be looking at, the final height would be 0, because stuff's going to jump up and it's going to fall back down. Okay? The initial velocity is the force I threw the ball with. And the initial height would be, well, how high was the thing when it started moving? So if I go back to my Mario problem here, it says, in his attempts to save Princess Mario, or in his attempts to save the princess, Mario must jump to many platforms. If he jumps straight up with a velocity of 18 feet per second, that's our velocity. That's our V. My velocity is 18 feet per second. After how many seconds does it take for him to land back on the ground? So I want to know the time. I don't know that. Now, they didn't say anything about a starting height or a final height. But think about it. If you're here, Mario, here's Mario. There, stick figure Mario. And he jumps up. Goes boing. Well, if he starts on the ground, here he is, his starting height would be 0. And let's say he jumps, and he lands. His final height would also be 0. Now, if I wanted to pretty up this little formula here, I don't really need this plus 0. I do need him, though. So check this out. This now is one of those problems that we were just doing a little bit ago. If I could figure out, if I could like factor this and then solve it, I could find out how long it took him to land back on the ground. So let's see here. Out of these both have a common factor of 2. 16 and 18 can both be divided by 2. And they both have a common factor of t. Now, if I factored out a 2 from this, I would be left with a negative 8t left behind. Negative 16 divided by 2 is negative 8. T squared, if I take away 1t, I still have 1t left. If I take 18t and divide by 2t, well, 18 divided by 2 is 9, and the 1t he had got pulled out front. It got factored out. So now I'm left with this. That is 2 factors being multiplied together is equal to 0. So either, undo that. Either 2t equals 0, or negative 8t plus 9 is equal to 0. I'm going to solve this guy first because he's easier. T equals 0. So that tells me that at time 0, if you imagine a timeline going here, at time 0, Mario was on the ground. This is before he jumped. Okay? He's going to jump, and I want to know at what time does he end up back on the ground. Well, if I subtract 9, negative 8t is equal to negative 9. Divide by negative 8 on both sides, and t is equal to 1 1/8 seconds. So Mario would land back on the ground in 1 1/8, which is 1.111. Ooh. No, that's not 1.1111. That's 1.125 seconds. So we figured out how long Mario was in the air before he landed back on the ground. Okay. Big, long, complicated problem. We're not going to do any more of those. But I wanted to show one so you can see an applicable use of why would somebody want to factor this. It's used a lot in physics. Alright. Now, in class yesterday, I had you folks working on up to number 21 because that's what we covered in class yesterday. We have now covered up to number 33. Let's see my time. 24 minutes. So at this point, we probably have about 10-ish minutes of class left. Here's what I want you to do. I would like you to work on up to number 33, let's see, do the evens from 22 up to 33. So 22 through 33 evens. And I'm going to have an assignment on Schoology. At the end of class, before you leave, I want you to submit what you have done. I only need this homework page, so you'll probably have what you worked on yesterday in class up to number 21, and then as well as this new stuff from 22 to 33 evens. Okay? By the end of class, I want that submitted. If you finish that, and there's time left over, you may work on something quietly. If the substitute would like, they may allow you to work in pairs. I'm fine with it. You folks have been working fairly well, but do understand that if they're letting you work in pairs, this still needs to get done, and you need to submit by the end of class. I'm going to grade it this weekend. Please don't make me put in zeros. All right? So, that has been the end of this lesson 9.4. I hope you folks have a nice weekend, and I will see you next week. Goodbye.